with left-hand rule and right-hand rule, where we make the rectangles, and then we pick the points, and if we do the left-hand rule, we do all the points except for the very last one, and if we do the right-hand rule, we do all the points except for the very first one. Now, that's not the only way to choose our points. All we need is 1 point from each rectangle. So this graph looks like this. Okay, and we're dividing it, say we're doing n equals 4. So we're going to divide this into 4 rectangles. This is 0, this is pi. We do delta x is pi minus 0 over 4. Pi over 4, so this is pi over 4, pi over 2, 3 pi over 4. Okay, is everybody okay with that part of it? So this is nothing different than left-hand rule or right-hand rule. All we're doing is making our rectangles. Left-hand rule, we would choose this point for the first rectangle. Right-hand rule, we would choose this point for the first rectangle. There's no rule that says we have to use either the left or the right. We could pick any point in that rectangle, or in this region, to define the top of our rectangle. The only requirement is wherever we choose, that's where the curve, where that point is, that's where it's touching the curve. Okay? Well, this strategy uses a different way of doing it, and it says, I'm not going to pick my point down here. What I'm going to do is I'm going to look up here and find where is the lowest place on the curve within this region. So where is the curve, so the curve here, where is the curve the lowest between 0 and pi over 4? 0. Everybody agrees it's 0, so we're going to pick that point for the first rectangle. So I'm just going to mark these points off in red. Okay, so that's the point in the first rectangle. Second one, where's the lowest point of the curve? Pi over 4, so we're going to pick that point. Unfortunately, when I do this in red, it just picks up all the black and smudges it around. But what about this rectangle? Where is the lowest point?
3 pi over 4.
At 3 pi over 4. And on this one, where's the lowest point?
Pi.
At pi. So our lower is going to equal delta x. It's always delta x. And then all we need to do is just add up the values of the function where I just put those red dots. Okay, so this is going to be f of 0, f of pi over 4, f of 3 pi over 4, and f of pi. Is everybody okay with that? And now let's do the upper. The upper is going to do the same thing, except we're going to pick in every region, we're going to pick the highest point in that region. I'll do these in green. So in this first rectangle, where does the highest point occur?
Pi over 4.
Pi over 4. This region?
Pi over 2.
Pi over 2. This region?
And that is, it looks like pi over 2.
Also pi over 2. In this region?
3 pi over 4.
3 pi over 4. Okay. And it's not even a problem that this point gets shared by both regions. That's not even a problem either. So now our upper is going to be delta x. And now the 4 green dots are at f of pi over 4, f of pi over 2, f of pi over 2, and f of 3 pi over 4. Okay? And so all we need to do is we need to just evaluate this function at those points and then multiply by pi over x, that's gonna give us the lower of the upper. Does that make sense, everybody? Okay. Now, what ends up happening is when we go to integrate this, when we actually do the integral, we're taking the limit as n goes to infinity. So this number of rectangles, these rectangles are getting thinner and thinner and thinner, and these 2 points end up squeezing together and coming to the same place. So we don't end up having a problem. This one will, and the advantage of doing it this way is this one will always give us an answer that's too low, and this one will always give us an answer that's too big. So if it's really, really, really important that we know that our answer is not too low or not too high by a certain amount, we can do this and guarantee that. With the left-hand rule and right-hand rule, we never know if our answer is too big or too small. It'll probably be more accurate than either one of these, but we don't know which side we're on. We know that the actual answer is going to be bigger than this one, but smaller than that one. Okay? And so this is just a different strategy for how to choose where to pick our points along the bottom. There's another way that tends to give even more accuracy. Instead of picking the left or the right, we just go right down the middle and pick the middle value every time. That's called the midpoint rule. Considerably more accurate than left or right hand rule. Okay? But as we take the limit as n goes to infinity, because these regions are all squeezing down to nothing, no matter how we choose the point, they all squeeze together. They just all get squished together. Does this make sense? Okay, so all you have to do is take these points and plug them in there. Now we're going to do it again with n equals 2, n equals 4, and then come back and do it again with n equals 8. But this is what you do. Just draw the picture, mark off your regions, and then just pick the lowest of each region, which means for the lowest ones, we're going to want to push to the outside as much as we possibly can. For the highest ones, we're going to want to push into the middle as much as we can.
So you plug those into sin x plus 2?
Yeah. Mm-hmm.
Like individually or? Like...
Individually, yeah.
Oh,
and you can just use the table function in the calculator, put that into y equals, and then just type in 0, pi over 4, 3 pi over 4 pi into the table, and it'll just spit out the answers, and you can.
And then you sum it?
Just add all those up, and then multiply by pi over 4.
Got it.
Okay. Any questions here? Okay. Any more questions from homework? Okay. And in these pictures, it's always going to be in these pictures, it's always has to be that the dark blue has to never go above any part of the curve ever, and the light blue can never drop below the curve at any point ever. So this one doesn't work because the light blue goes above, or the dark blue goes above the curve, and this one doesn't work because the light blue drops below the curve at some point. So, so this is the correct one here. The dark blue is never. If we tried to raise this line at all, it would now all of a sudden cross some of the curve here. Okay. Any other questions? Okay. Any more questions from homework? Okay, so let's look at the practice exam. So there's a lot of stuff on here so I changed how I'm doing final exams a little bit this semester. There's a lot of stuff on here that's not going to be included, so I'm just going to skip over that stuff. And so let's talk about this before we get to that. There's basically going to be 3 things on the phone. We're going to have limits. We're going to have derivatives. And we're going to have integrals. Okay. And for limits, we have factor and cancel. we have L'Hopital's rule. And then limits to infinity. Basically, this means the limit as x goes to infinity. F of x. Okay. And it's just gonna be some of each of those. Now, on the factor and cancel ones, you always have the option to do L'Hopital's rule on those, because the factor and cancel is when we get 0 over 0, and 0 over 0 is a case where L'Hopital's rule will work. So you don't ever have to do the factor and cancel, but it will be an option available on a couple of problems. If you decide to always use L'Hopital's rule, then that's fine too. However, there will be some where the factor and cancel won't work. You'll have to use L'Hopital's rule on those. Okay? And then these limits to infinity, those are the ones where we compare the degree top and bottom. If they're the same degree, then it goes to coefficients. If the top has higher degree, it goes off to infinity. If the bottom has higher degree, it goes to 0. Those type of limits as well. So it's just gonna kind of be a mixture of those. Just a few of those, yeah.
When you say derivatives, is it literally only derivatives, or are we doing anti-derivatives as well?
Well, that's the integrals or the antiderivatives. Antiderivatives are just a type of integral. Okay, so derivatives. Really, derivatives are just gonna come down to product rule, quotient rule, chain rule. A couple of them will be a little bit more complicated where it involves more than one rule. Some of them will be pretty straightforward where here's just a product rule, here's just a quotient rule, here's just a chain rule. So. And then integrals will have definite.
It's kind of hard to see.
And indefinite. And then U substitution. Okay, so there'll be this is just a copying what I have on the bottom of there. All right, so for integrals, we'll have definite integrals where we have limits of integration, indefinite where we don't, and then U substitution, yeah.
Will we still be able to have like a page front and back?
Yep. Mm-hmm. Yeah, absolutely. You can have a page of notes, front and back, whatever you want to put on it. I assume you're going to put all the derivatives on it, put all the antiderivatives on it that we know, and then the rules for the limits, that sort of thing. Yeah, you can put on it whatever you want. Okay. Any questions about this? Yeah.
Do you perhaps know like the units we can like refer back to?
Okay, so limits are, so chapter 2, so limits are chapter 2. And 4.4 for L'Hopital's rule. Derivatives are all 3.1 through 3.6, and I'm not going to do any implicit differentiation. It'll just be here's a function, take the derivative of it. And then integrals, this is all chapter 5. So 4.9 and 5.3 through 5.5. My whole point of what I'm asking you here is these are the skills that are absolutely essential to be successful in Math 280 and beyond. So you have to be able to do this to at least meet the skills that are necessary for next semester. Okay. Now the integrals, we didn't have a lot of time on them, but that's pretty typical for this course. And so we did a lot of just kind of real basic examples. That's mostly what this course is, other than the U substitution. U substitution is really kind of the only technique that we have now, other than just the basic formulas. And Calc 2 starts off with doing more stuff with integrals. So Calc 2 is really more about the integrals in this class. This is just a real quick introduction to it. So. Okay.
Are we gonna be able to put examples of all?
Yeah, we will do examples of all of these as what we're gonna do today. So.
Okay, perfect.
Okay. Yeah.
Are you writing all of the derivatives and integrals?
You want me to do that right now?
Yeah.
Yeah, I can do that. Okay. So. We'll have our trig functions, derivatives, sin x.
An example of each.
19. I forgot. I don't know my first page. I don't even know if this is the right one. The 19? It is 19? It says 19 on one. But it goes up, the last one is 19? Oh, yeah. I don't know where the front page is. I lost it.
So those are the derivatives that you need to have. And then antiderivatives, sin x, negative cosine x plus c, cosine x, sin x plus c.
Yeah. Mine.
These are all the intervals?
Yeah, derivatives and intervals that we're gonna need, that you're gonna wanna have, secant squared x. And then we need the rest of them. Let's see what all got. is it? I think it went along the way. Okay. Oh, I forgot, piecewise. Piecewise limit also.
Oh, no.
Okay, so here's some examples of some limits. Okay, so the first three of these are straight out of chapter 2, and then the last one is the L'Hopital's rule on theirs.
We're skipping number 1, right?
Yeah, we're gonna skip over number 1, and there's not gonna be anything like that in there. So I'm just gonna be skipping over anything that's not gonna be on the exam.
Okay.
Number one's not gonna be on there.
There's not gonna be anything like that. There's not gonna be any word problem stuff. It's just, here's some, just problems like this. And go ahead and do those. Okay. Limit as x goes to 2 of square root 5x squared minus 3x plus 2. What do we do here?
Plug in the two.
Yeah, always, every limit we ever do, we always want to plug in the value first and see what we get. Well, not piecewise, that doesn't apply, but any of our normal functions. Just plug in the value first and see what you get. If you get an answer, that's your answer. If you get 0 over 0 or infinity over infinity, then we know, well, 0 over 0 gives us the option, we can do either factor and cancel or L'Hopital's rule. Infinity over infinity is basically just L'Hopital's rule.
I got 4 when I plugged in.
You got 4, okay, so we're gonna get square root of 5 times 4 minus 3 times 2 plus 2. It's 20 minus 6, so square root of 16, which is 4. Okay. B.
Is that, that's a plus, minus plus, right?
5 times 4 minus 3 times 2 plus 2.
But
Oh, no, not plus or
4.
minus. It's only plus or minus when, if we had this, this would be plus or minus 4. But when we do this, this is just 4. The square root symbol itself always means the positive version of it. It's when we're solving equations that we could get the thing. Technically, when you take the square root of both sides, this is the one that gets the plus or minus, not that side. This side would just be 4, this would be plus or minus x, because if x is positive, we would get positive. But if x was negative, when we squared it, we'd get positive also. But, okay, yeah, so that would just be 4. Here, so limit as x goes to 3 of x squared minus 7x plus 12 over x squared plus x minus 12. What do we do here?
Plug it in.
Plug it in. Still, we plug it in first. We're going to get 9 minus 21 plus 12, which equals 0 on the top. And 9 plus 3 minus 12 equals 0 on the bottom. So this is a 0 over 0 case.
Factor and cancel.
So this one, we could absolutely factor and cancel it, or we could use L'Hopital's rule now. So back in chapter 2, our only option was factor and cancel. Now we have the additional option of L'Hopital's rule, but let's just factor and cancel this one. We'll do a L'Hopital's rule one later. Okay, so how does this factor? X minus 4, x minus 3 over x plus 4, x minus 3. Those cancel. Now what do we do? value. So we're gonna get 3 minus 4 over 3 plus 4. Negative 1%.
When I was looking back over this, I completely forgot, and then it's a lot easier than I remember.
Yeah. So when we were first learning it, is not only were you learning the new concept of how to do limits, but also you were relearning how to do the factoring part of it, and so it just is a lot to hit you right at once at the very beginning of the course. So now you've got a lot of practice with the factoring, and the calculus part of it's pretty at this point is just kind of, yeah, we've been doing this all semester, so. All right. C, we haven't done much with piecewise functions since chapter 2, so these are gonna be a 2x, x is less than 4, and x cubed. Okay. So we're coming at 4 from the negative side. So which of these are we going to use? Top one. So it doesn't even matter that 4 belongs to this one because we're not at 4, we're just approaching 4. So we're coming at 4 from the negative side, which means we're below 4, so we're going to use this top definition. And now what do we do?
Plug it in.
Plug it in. So this is just going to equal 16 minus 8, which is 8.
What does it mean when we use the top?
So because this is coming at it from the negative side, we're going to pick the one that's less than.
Okay.
And so we're going to, instead of this messiness, we're just going to use that one. What would change if this was a plus instead of a minus?
We move to the bottom one.
We would switch to the bottom one. What if there was nothing here at all? What if it was just x goes to 4?
We use both?
Then you use both of them. Because 4, we could, depending on which side we're coming at 4, we could come at it using either one of these functions. So you would have to use both of them if there's no plus or minus here. Minus, you use the one that's less than. Plus, you use the one that's greater than. Nothing up here means you have to use both. Okay. Any questions there? Okay. D.
There's a negative on the two.
Oh, from the negative side. Okay, what do we do here?
Plug it in.
Plug it in. We always plug it in, so this is going to be tangent of 0, which is 0, over 0. So this is a 0 over 0 case. So what options do we have?
We use L'Hopital's rule.
So L'Hopital's rule. This one's not going to factor and cancel because of the trig function in there. So trig, exponentials, logs, those types of functions don't work with the factor and cancel. So for those, we're pretty much stuck with L'Hopital's rule. Okay, so we're going to apply L'Hopital's rule. And what does this become?
Secant 2x over.
Secant squared x over 1. And now what happens when we plug in 0?
But then we know
0 over 1.
So we're taking the derivative of the tangent. So we look over there, derivative of tangent is secant squared. And derivative of x is just 1.
It'd be 0 over 1.
So secant of 0 is 1. And so this just comes out to 1.
What rule says that secant squared is 1?
Secant is 1 over cosine. And cosine, so secant of 0 is 1 over cosine of 0. And cosine of 0 is 1. Yeah.
Why are we doing, secant square x over one? Why is the one there?
So we're taking the derivative of tangent,
Uh-huh.
gives us that, and the derivative of x gives us that. So L'Hopital's rule, it's not the quotient rule, we're not taking the derivative of the whole thing, we're just taking the derivative of the top and the derivative of the bottom. So this is an application of the derivative, it's not the actual derivative itself. It uses the derivative as part of the process, but it's not an actual derivative that we're taking. So we're not gonna use the quotient rule.
And then why are we doing 1 square?
So now we plug in 1, so this would be, or plug in 0, so this would be, secant squared of 0 over 1,
Oh, yes.
and secant of 0 is just 1.
So we're gonna need the unit circle for.
Yeah, I would recommend having the unit circle available to you. And knowing also that the ones that don't show up on the unit circle, so tangent x is sine x
Sine
over
over
cosine
cosine.
x. Secant x is 1 over cosine x. Cotangent x is cosine x over sine x. And cosecant x equals 1 over sine x. And on the unit circle, sine x is y, cosine x is x. Okay.
What are those called?
These are the, right, no, these are not the right angle. Right angle ones are the opposite over adjacent thing. I don't know what these are called. These are just the connection between the trig functions.
Okay.
So the unit circle only shows sine and cosine. And so you have to get the rest of them by using these.
So like, for example, if you have the sign of something, the reciprocal is just swap
1 over, yeah.
the places.
Yeah.
Like if it's on the.
Mhm. So if it's
on the
square root of
top.
2 over 2, it'd be 2 over
Yeah.
square root of 2.
Okay, mhm.
Okay. Any questions about the limits?
For E, the fact that it's approaching from the left has basically no relevance, right?
Yeah, because at this point, once we plug in the value of 0, once we got to this point, it's, we don't have the issue from left or right anymore because we can plug it in. If you can plug it in, it doesn't matter if it's left or right. Usually that only matters when either you have a piecewise function where they come in like this, or if you have an asymptote, sometimes one goes up and one goes down. But in this case, because we didn't get an asymptote, it doesn't make a difference. Yeah.
On the front exam, when we're finding limits, do we have to find limits through like fractions or radicals?
Yeah, so fractions, definitely some fractions like this. There might be some radicals. I mean, that one has a radical in it. Yeah, basically any of the types of functions are fair game for those limits. So. I mean, definitely rational stuff like this. That absolutely will be stuff like that on the final. Oh, there's one more example that I want to do of this that I don't have on the practice exam. Okay, so the limit is x goes to infinity type problem. What are we gonna do here?
not where if the exponent is the same, we only deal with the exponents and get rid of everything else.
Yep, so when the exponents are the same, we just look at the coefficients. So what is this one gonna be?
3/9.
3/9. Or you don't have to reduce your fractions on it. Do not have to reduce your fractions on the test. You can if you want, but you don't have to. Yeah.
Is that because it's an infinity?
Because it's an infinity, that rule of checking the degrees stuff only works when we're going to infinity. If we're going to another number, then it's probably going to be a factor and cancel or a L'Hopital's rule question.
Same with negative infinity?
If it goes to negative infinity, same thing.
Okay.
So whether it's an infinity, negative infinity, plus infinity, anything with infinity, we can do this.
Yeah. Yeah.
And that is so the highest degree on the top and the bottom have to be the same.
Yes. Highest degree on the top and highest degree on the bottom have to be the same for us to switch to coefficients. What if the top has higher degree? Well, we can't do the coefficients, but we still can do the limit. If the top has higher degree, then what is the limit gonna do?
Take whatever is the highest exponent.
So if this was 3x to the 5th, how would our answer change?
You leave the x, like, 3x, no, I have it in my notes.
What was that? So no, it wouldn't be 3/1. So if we had, let me write it. Yeah, so when there's, whenever we have a fraction like this, there's always a tug of war going on. The top is trying to pull it up to infinity, the bottom's trying to pull it down to 0. Whichever one's bigger is gonna win. In this case, they tied, so they landed somewhere in the middle, which happened to be 1/3. This one, which one's gonna win?
Positive infinity?
Top is gonna win, it's gonna pull it off to infinity. Now, you do have to be careful though, because if this was a -9, we'd have a positive divided by a negative, which does what? Negative, and that would send us to negative infinity. If you're not sure on the exam, you can always just plug in a really large value for x. If you're getting a really big positive number, it goes to positive infinity. If you're getting a really big negative number, it goes to negative infinity. But we can figure it out based off of these coefficients. If we're going to positive infinity, it just comes down to the coefficients. If we're going to negative infinity, it also is affected by the difference between these two. But this one's positive infinity. If you're not sure on the exam, you can just plug in really large values for x and see whether you're getting positive or negative, and I'm okay with that.
So could you could like plug in 5 for x, and then,
If you think 5 is a really large number, then yeah, maybe like 1,000.
oh, okay.
So, yeah, I would definitely not stay too close to 0 because it can do this for a while before it shoots off. So it might be, if you plug in 5, it might be hitting negative, it just happen to hit negative at that point and then come back positive. So we want to do something that's not close to 0 at all, so.
Can you try one like that, kind of, how you're saying?
Okay.
Like, and what is this called again?
These are just limits, limits to infinity. So this is what I have over there. Okay, so this one's going to negative infinity. So to determine pretty clear, immediately you should notice that the top has higher degree than the bottom, and that tells us something, but then we still have to figure out whether it's positive or negative. So go ahead and try to figure that out, whether it's positive or negative. If you want to use your calculator and just plug in a large number, you can do that. Now this is negative infinity, so we want to plug in a large negative number
Into the whole thing?
into the whole thing.
the large number, will we plug in for all the x's then?
Plug in for all the x's.
Same number, right? It
Same
has to
number.
be.
So I'm doing it through, gonna use the table to do it. You can do it by hand on the main screen, either way, but I just typed in my function here. I'm gonna go to the table on my calculator, I have to change it back to ask every single time I do this. Table, and I'm just gonna pick a really large negative number. And what are we noticing for our answer? It's negative, so this means 10 to the 12th, so we're getting negative 10 to the 12th there. And so what's our answer here?
Negative infinity.
Negative infinity. Okay, and then what if we have limit as x goes to infinity of 3x plus 1, 5x squared plus 2?
Would be 0.
Does everybody agree with that? Who's gonna win the tug of war here?
The black.
The bottom's gonna win the tug of war, and it's trying to pull always trying to pull things to 0. And here we don't have to worry about plus or minus, because there is no plus or minus 0. It's just gonna be 0.
So we don't even bother checking with the calculator.
Don't need to check the calculator this at all. And the only reason on this one you might want to check on the calculator. Now we could do this without the calculator here. So if we ignore these terms, we're just going to ignore those terms because they're insignificant. It's the only thing that matters for these polynomials is what is the largest degree term when we're going to plus or minus infinity. So I'm just going to ignore those. So we have 7 negative infinity to the 4th, 5 times negative infinity to the 1st. Okay? We're not really plugging this in. This is just kind of a scratch paper type of argument that we're making here. But let's just evaluate signs. Okay, so 7, is that positive or negative? Positive. Negative infinity to the 4th. So it raised to the 4th power.
This thing's negative.
Positive.
So anytime we raise something to an even power, it's going to be positive no matter what it started as.
Oh,
If we raise it to an odd power, it's going to stay the same sign as whatever it started as. So this is going to be positive. On the bottom, 5,
positive.
positive. And negative infinity, negative. Overall, what does that make?
Negative.
So we have positive, positive on top, we have positive, negative on the bottom, so this is positive over negative. This whole thing is going to come out negative.
Why'd you put 0 for that one?
For this one?
Yeah, wouldn't it be negative infinity?
So this is trying to pull it off to infinity, this is trying to pull it to 0.
Oh, not negative infinity?
No, so it's sucking in, so one of them is pushing out in both directions, one's sucking in towards the middle.
Because the x is higher on the bottom.
And then
right?
behind one on the bottom, yeah, so the confusion is just, one's pulling this way and one's pulling that way, which isn't what it does. One pushes out, one pulls in. And the case that we have here is it pushes out, but we don't know if it's pushing out that way or if it's pushing out this way. That's why we have to do something with the calculator or something like this. Either way works. Okay? Any questions? Okay. Everybody good with the limits? like this. Discontinuous, so we can worry about, okay, derivatives. Okay, so now it's just some basic derivatives like these first two, and then some product rule, quotient rule, chain rule stuff that you should be able to do.
So number 3, we ignored,
Number 3 we ignored, yes.
and number 4,
Yeah, that whole page. So we did the limits. Now we're just gonna do derivatives, which are all like problem number 7. And then all the way to the end, problem 19. Those are the problem 2, problem 7, and problem 19 on the practice exam are the ones that are going to be on the plate.
So the rest is just extra.
The rest is stuff that I put on in past semesters, but I decided this semester not to.
How many questions in total?
It really kind of will be 3, but it'll be 3 questions like this, where
With
there's
parts?
multiple parts, so, I don't know, maybe 5 or 6 limits, 6 or 7 derivatives, 6 or 7 antiderivatives, something like that. So. Okay. So y equals cube root of x. How do we deal with this?
The power of b over a, so 1/3, x by 1.
So this is x to the 1/3. Are we done? No, we haven't, we just changed this form. We haven't integrated, or taken the derivative yet. What's y prime gonna be?
It'll be 1/3 x to the power of -1 or -2/3.
Okay. So y prime is just 1/3 x to the -2/3.
did you leave the -2 on the top? On the, no, it applies for the whole thing, right?
Yeah.
This negative?
Yeah.
It doesn't matter. If you have a negative on a fraction, you can put it on top, you can put it on the bottom, or you can put it out in front. It all gives you the same answer. So what are we gonna do here? We'll go ahead and do this one. Just go ahead and do it. Should be able to do this one. Okay, so what are we gonna get?
18t to the second.
18t squared
Minus 10
minus 10t plus 7. Any questions there? Okay, 3x squared minus 5 to the 17th.
17.
What, go ahead.
Chain.
Chain
So
rule.
we're gonna chain rule, go ahead and do that. So for each of these, I'm just gonna have you guys work on them first, and then we'll talk about those.
I don't think so. I think I got it right.
Okay, so what are we gonna get here?
17 times 3x to the second. Minus 5. Times 2.
Over 16.
So 6x.
Raise to the 16th
Oh, yeah.
times
6x.
times 6x.
Both times, not plus.
And it's times, it's not plus, yeah. You don't have to put the time symbol in there, but I tend to do that. All right. Any questions here? If you want to multiply 17 times 6 and move the x to the front, which is how we normally would write it in this, we would usually take that x that's outside the parentheses and put it in front, and take the 6 and the 17 and multiply those together, but you don't have to do that. Okay.
I have a question.
Yeah.
On mine here, I did this last night, software example question. What is this applying?
That
Is it the, like, why would I do this?
this looks like it's a product rule on this. So you're doing second derivative.
Oh, it's the second derivative.
Okay. D?
Quotient rule.
Huh? Okay, okay, quotient rule, yeah. X squared minus 2 square root x all over x. Is everybody okay with the quotient rule here?
Yeah.
Add one more to the list over here that. Technically, this one's included in this one here, but what's the derivative of square root of x?
1 over 2x squared.
2 square root of x. Pretty sure that was the symbol you were thinking
Yes.
of, and just had it wrong. Okay, so square root is 1 over 2 square root of x. Okay, so quotient rule, go ahead and do it. Quotient rule is. Okay, so what do, so we have our top and our bottom for the quotient rule. What do we get when we take the derivative here?
2x. And I think it's negative 1 over. 1
X to the
over
negative
2x squared.
Square root of x.
Yeah, I'm sorry,
Times.
saying it wrong.
Times 2, right?
Yeah, so you lost this 2 here.
I did.
So the 2 should be 2.
So pretty much the state, the 2 we put aside or any.
Yeah, you can
number.
leave it, you leave it in front or put it on top, either way works.
No, like, to solve that, like, we just focus on.
Yeah, just ignore the 2.
And then whatever number it is, and we
Just bring it
take
back.
So question, if there is no 2, then it would be 1 over.
1 over 2 square root of x, yeah.
Or if it was a 5, then it would be 5 over.
Yeah.
whatever.
Yeah, so, like Leona was saying, if there's a number in front, just ignore it at first, write down what you get, and then if there was a number there, then just throw that back in at the
No,
end.
1.
Okay, and x becomes
1.
1. So now we're doing this, and so we're going to get f prime of x to be 2x minus 2 over 2 square root of x
Minus.
times x minus 1 times minus 2 square root of x divided by x.
I left the one for the last, like I put the number 1 to like, and
That's fine.
it doesn't matter.
It doesn't need to be there.
So you said you would be like that?
All right. Any questions there? Yeah.
Is also, square root of x also 1/2?
X to the 1/2, yeah. So that formula is just a special case of this formula here. So we could write that as x to the 1/2 and then
Mhm.
bring it out in front and subtract 1 from the x one, but it comes out to that. So it's one that, I know it's a special case of the x to the n rule there, but square root shows up often enough that it really is, makes your life easier if you just have that one memorized. Any questions so far on the derivatives? Okay. E. Okay, so go ahead and do E. Get back and see that. So what rule are we gonna use here? Another quotient rule, so we have our top and bottom, what's the derivative of x plus one?
Just
One, and here?
3x squared plus 1.
X squared plus one. And so y prime is going to be this one, one times x cubed plus x minus two, minus the other one, all over
X cubed plus x minus 2.
Is it still right if I switched the x plus one?
switch these?
Yeah.
Yeah, that's fine.
Okay.
Yeah, you can switch out, you can write them in either order within the term, but you can't switch the terms. All right. Questions here? Let's go ahead and take a 10-minute break. We'll come back at 10:50, and then continue on with some more derivatives, and then we'll get into the integrals.
I guess you didn't want